Hello guys, welcome to my channel. Today we're going to discuss heap memory and stack memory in Java. Let's get started. Generally, memory is divided into two big parts, the stack and the heap. The memory structure would pictorially appear somewhat like this. What is this stack memory? It is a thread-specific memory area and contains local variables, methods, call information, etc. It is responsible for holding references to heap objects and for storing value types, also known in Java as primitive types, which hold the value itself rather than a reference to an object from the heap. The stack uses LIFO data structure, or last in first out. When a method is invoked, it creates a new block in the stack for that particular method. The new block will have all the local values, as well as references to other objects that are being used by the method. When the method ends, the new block will be erased and will be available for use by the next method. The objects you find here are only accessible to that particular function and will not live beyond it. The variables on the stack have a certain visibility, known as scope. Only objects from the active scope are used.
I know an example. Suppose we do not have any global scope variables, fields, and only local variables. If the compiler executes a method's body, it can access only objects from the stack that are within the method's body. It cannot access other local variables, as those are out of scope. Once the method completes and returns, the top of the stack pops up, and the active scope changes.
Absolutely right. I guess you noticed that in the memory picture that I showed before, there are multiple stack memories displayed. This due to the fact that the stack memory in Java is allocated per thread. Therefore, each time a thread is created and started, it has its own stack memory, and cannot access another thread's stack memory. You also need to keep in mind that JVM stacks could be a fixed size or variable size. If computation in a thread exceeds its stack size limit, then JVM throws stack overflow error and exits. Consider that your main method calling method M1, public void M1, int equals 20 in the stack Java, a frame is created from method M1, and the variable A is created in it. Let's see how it would look like. Now suppose method M1 is calling method M2 in the Java stack. A new frame is created for M2 on top of the frame M1. Let us have a look at it. Let us move on to heap memory now.
Yeah.
This part of memory stores the actual object in memory. Those are referenced by the variables from the stack memory. It is created when the program is run, and its size may decrease or increase as your program runs. It can easily become full, and when it does, garbage collection is initiated. This is when objects that are no longer used are deleted to make way for new objects. Unlike in a Java stack, where memory allocation is done when your program is compiled, in a heap it is allocated as your program is run. For example, let's analyze what happens in the following line of code. String builder d equals new string builder. The new keyword is responsible for ensuring that there is enough free space on a heap, creating an object of the string builder type in memory, and referring to it via the d reference, which goes on the stack. This is how it would look like. Once the method has completed its execution, the flow of control will go back to the calling method, which in this case is method M2. The stack from method M3 will be fleshed out. Since the reference variable will no longer be pointing to the object in the heap, it would be eligible for garbage collection.
What if object has a reference as its instance variable? Suppose there are two classes. Class A, B child equals new B, in B, / more code. Class B in C, in D, / more code. Public static void main, string args, apparent equals new. So in this case, how would the diagram look like?
Ha 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 ha. I get it. In this case, the reference variable child will be created in Heap, which in turn will be pointing to its object, something like this diagram. The heap itself is divided into a few parts, which facilitates the process of garbage collection. We will discuss that in another video. So let's summarize. When a method is called, a frame is created on the top of the stack. Once a method has completed execution, the flow of control returns to the calling method and its corresponding stack frame is flushed. Local/reference variables are created in the stack. Instance variables are created in the heap and are part of the object they belong to. There exists only one heap memory for each running JVM process. Therefore, this is a shared part of memory regardless of how many threads are running. So we are pretty much done for now.
Ah, that was awesome. I think I am ready for the interview. Looking forward to the next class.
If you find this video useful, then please don't forget to hit the like button and subscribe.